Welcome to Object-Oriented Programming. In Python, we use classes and objects to create custom structures for our programs. Think of a class as a template or a blueprint, and an object as the actual item built from that blueprint. This approach helps us model real-world concepts efficiently. To visualize this, imagine an architectural blueprint for a house. The blueprint itself isn't a house, you can't live in it. It's just the design. However, you can use that single blueprint to build a dozen identical houses. In Python, the class is your blueprint, and every object you create is a unique house based on that design. Defining a class in Python is simple. We use the class keyword followed by a name, typically capitalized. Inside, for now, we use the pass keyword just to keep the code valid. By calling the class name with parentheses, we create a new instance, or object, and assign it to a variable. The anatomy of a class is defined by its name and its body. Everything indented underneath the class declaration belongs to that blueprint. This indentation is crucial because it tells Python which variables and functions are part of this specific structure, keeping your data and logic bundled neatly together. Here, we've created a car class with a color attribute. By writing my_car is equal to car, we instantiate the class into a real object. We then use dot notation, the period after the object name, to access the specific attributes defined inside the class. It's like looking at the property of the car we just built. Now that we have a class, we need a way to store information about our objects. We call these attributes. Think of these as characteristics. For a car, attributes might be the color or the model. By assigning values to these variables within a class, every object we create gets its own data. To retrieve an attribute, we use dot notation. You simply type your object's name, followed by a dot, and then the attribute name. In this snippet, we access the color attribute of our my_car object. Python looks inside that specific instance and pulls out the value we stored there. The __init__ method is a special function known as a constructor. It runs automatically the moment you create an object from your class. It's the perfect place to set up the starting state of your object, like assigning a specific name or color the moment the object comes into existence. You'll notice the word self used everywhere. Self is a reference to the specific object currently being created or used. It tells Python, hey, store this color value inside this specific car object, not another one. Without self, Python wouldn't know which object's data you want to modify. Classes aren't just for data, they can also perform actions. We call these methods. A method is essentially a function defined inside a class. By adding a drive method, we give our car object the ability to do something. Just call it using dot notation, and your object comes to life. Once you have your class, you can create as many unique objects as you need. Think of it like a cookie cutter. The cutter stays the same, but each cookie is its own separate piece of dough. Because each instance lives in its own memory space, changing the data in one object won't affect the others. Here is a vital tip. Always include the word self as the first parameter inside your methods. If you forget it, Python won't know which specific object instance you are trying to modify. This is the most common reason for a type error when beginners start building their own custom classes. Visualizing it this way, you can see how one single blueprint or class defines the structure for all the individual houses or objects that follow. You've now mastered the foundation of object-oriented programming in Python. Up next, we will explore how to make these objects interact with each other in more complex ways. To wrap up, remember these three core concepts. Classes act as reusable templates, allowing you to define the structure of complex data. Objects are the specific, unique instances you create from those classes. Finally, always use the init method and self keyword to cleanly manage and assign state to your objects. Let's test what we've learned. Which of these is the correct way to create a new instance of a class named car? If you chose B, you are exactly right. In Python, you simply call the class name followed by parentheses to trigger the creation of a new object. To wrap up, remember these three core takeaways. First, classes are your reusable templates for structure. Second, objects are the individual products created from those templates, each holding its own specific data. Finally, the combination of the initializer method and the self keyword is how we manage that data effectively.